Good morning, good afternoon, good evening, depending on your time zone. I'm Daryl from Indiana University. Peter will be joining us in a few moments, but first I wanted to give some background on the MDPI project at Indiana University, an initiative to digitally preserve all significant audio, video, and film at Indiana University. In 2017, we set out with the goal of digitizing 25,000 reels of film in 3 years, completed in 2020. Our preserved titles and where we're at right now. You can see big numbers from AV, which is principally finished at this time. And I'd like to point out that despite obstacles, including a shutdown for COVID in the spring, we recently passed the 20,000 reel mark, which was a real huge milestone for us. Here's just a look at our daily update of the formats that have been digitized. We plan to QC 100% of the mezzanine files and 10% of the preservation masters, around 16 hours of content a day. Obviously, checking all this manually would not be possible. So we needed a solution that would allow us to fast identification of potential defects and a way to report these defects back to the vendor. I should add, before the package makes its way to the QC team, it's sent through a very rigorous auto QC system. This was built by Brian Wheeler at IU Libraries, and you can see his diagram down below. Basically checking all of the durations, bitrate, codec, frame rate, making sure all the files match each other. Once the package is delivered and processed through the VidiCert analyzer, the QC specialist pulls up the files on a workstation, confirming completeness, image and audio loss or corruption, playback speed, overall faithful representation of the original. For the access copy, we're looking for minimal frame lines and acceptable color correction for faded stocks, and lastly, to create a QC report that lives on with the preservation package, or a fail report that is delivered to the vendor. A few identified defects: dirt and dust, gamut, clipping or crushing, foreign objects, in this case it was a piece of tape that wasn't removed, and color correction error, where the color correction was applied one frame too late. We had an issue where some scans were being captured crooked at one point, as you can notice by the upper perf appearing larger than the bottom perf. This was identified by one of our QC specialists, and we were able to identify and rescan all affected files. Earlier on, we identified in VidiCert Spectrum View a high-frequency tone being introduced into files using the optical reader. We then switched to a software-based solution for reading audio, which led to interstitial-type dropped audio samples. This was eventually fixed by the scanner manufacturer through a lot of R&D work between us and the vendor. Framing errors. You can see that a splice bump more than likely led to an image loss in the overscan. This would be a rescan for us. A couple of things that can be identified in the VidiCert striping image view is unsteadiness and faded stocks, and of course the exported PDF report. I'll throw it over to Peter now for a look at the technical aspects.
Thank you, Daryl. I would like to give you a bit more on technical information, how the quality control system works and how effective it is in real operations. Here you can see a simplified version of the quality control workflow, starting with the top left of this diagram with film scanning, which is done on-premise. Film scanning is providing the scan data, in this case DPX files and ProRes files, do the quality control step, which is actually consisting of two steps. The first one is an automatic analysis, so where the system detects specific issues you can configure in an automated way and is preparing information for the second step, in which an operator is really using this prepared information for making quicker decisions about the quality or whether it is acceptable or not acceptable. If the file is rejected, then a PDF report with the issues is generated in the QC system and is reported back to the service provider. In case the file is acceptable, then this PDF report, but additionally a fully detailed XML report is used to document the process and becomes part of the archival package. At the bottom of the slide, you see some operational information. On the scanning side, the service provider is operating with two scanners in 2 6-hour shifts per day and is creating up to 16 hours of content per day. In the QC side, we have to see that there is the QC of the overscanned material And there's also the QC of the cropped versions. So in QC we have up to 32 hours of content per day, and this is carried out by using 3 analyzers, in this case here, and with 3 summary stations for interactive work. The QC throughput of one QC operator is about 50 files a day, which corresponds roughly to 15 hours of content. If we would do that 15 hours of content in a full manual QC approach, this would roughly take 30 hours. So with our semi-automized approach here, we can gain about a factor of 4 in productivity in doing the QC in a very high quality. This slide provides you an overview on the different automated functions for finding scanning issues. On the visual side, you have functions for checking for under-overexposure, freeze frames, checking framing errors because of perforation issues, checking dust and dirt level, checking unsteadiness, continuous unsteadiness, or checking focus of the scanning equipment. On the audio side, of course, it's also relevant to check whether there is audio at all, if there is some specific superimposed sounds which shall not be there. In this slide, you can see the main functions of the interactive verification system, but I think it's simplest if I show you them really in live to see it operational. What you see here is the user interface for the QC operator, which shows actually all the results from the automatic analysis. For example, there are different timeline-based views, quality measures here at the top, like how much dust is in the film, how unsteady is film transportation, and other measures regards to luminance, so overexposure and underexposure. Some more information over time here, some visual aid for navigating and checking the content completeness. Then on the audio side, having information about loudness and specific audio issues. At the bottom, in the middle, you see a list of detections. So detections with a time point in and time point out, where there are suspicious sections which should be checked by an operator. And on the bottom right, you see a full-featured movie player, which, for example, allows you also to set the playback frame rate for checking interactively whether the metadata provided within the scan are correct or not. This is a function heavily used at, for example, at Indiana University. So what would be now the typical steps an operator would use to finding out whether a file is acceptable or not? One major thing is always to use the defects found by the automated system and to check whether they are real issues or not. For this, you can navigate to a specific location within the video by just double clicking here. You can loop play the film. In this case, you see that the picture is jumping out and in, so there is some, we call that a framing error. And in this case, the operator just gives the information, yes, I approve that there is an issue. Then the system would go to the next entry. A second way of working with the automated results is here in the top with using the quality measures. For example, if you have an unsteadiness indication, so high unsteadiness over a longer period of the film, you see here actually an example where there was an issue in the wet gate, and this caused some unsteadiness. If we would have that situation, high unsteadiness in this curve all over the scanned film, then this needs to be checked much more closely. If you have that just for one shot, that's not an indication of having a systematic scanning issue. Then there are other means of checking the content, for example, checking the start title and the end title, checking whether there are longer sections of black or white film, checking on the audio side. For example, we have here the audio spectrum, which shows you the different frequencies of the audio signal over time. And if you would have one specific frequency like here, this ingredient of all flour mixtures. This very high frequency tone, 7 kHz, is, for example, a superimposed sound from the audio system, which should not be there. So if you have in this audio spectrum sounds at a specific frequency all over the time. For example, if you have hum from beginning to the end at 50 Hertz or 60 Hertz in US, then that's an indication you should check also the scanning equipment. And of course, if the QC operator came across during this work also to other kinds of defects, he can add always manually specific defects here from a predefined list. At the end of this process, he's going here on the top right, he's going to make his decision whether it's acceptable or not, and he should also give always comments about his decision. These are the most important informations to be discussed with the service provider for scanning. Coming back now to the presentation, in order to find out how effective such a QC system in such a high volume film digitization project is, we have done some statistics from December 17 until September 2020, where almost 80,000 reels have been digitized, producing 35,000 files. Almost 10,000 hours have been QC'd in this time. What we have done, we want to compare those files which have been accepted, so which went actually to the archive, and compare them against the files which were rejected for either rescanning or remastering at the service provider. So here you can see now the result of that analysis of these operations of the last almost 3 years. You see here the statistics of defects which are actually verified defects. So these are defects which has been first reported by the automated system and has been approved in the interactive step by the QC operator, or these are defects which have been manually annotated by the operator. So in any case, these are verified defects. You see here on the horizontal axis, you see the different types of defects which has been approved or annotated, from dirt, framing error, gamut clipping issues, crackles, splices, bloom range error, unsteadiness, and so on. And on the vertical axis, you see the average defects rate per file in all of these files, but the average defects rate. And this is divided in two classes. So the files which were rejected to the service provider, and the other files in green which were archived. So which conclusions we can draw from the statistics? I think the first one is, of course, when looking to that red bars, those bars indicate that specific kinds of defects, for example, dirt, framing error, clipping, so over underexposure issues, crackle, splices, and so on. So those are the most frequent ones. So there are many defects there, and they could be detected by the QC system. That's the one conclusion. The other story is, of course, to which degree this kind of issues can be reduced. When cumulating now all the different defects in the files rejected and cumulating all the different defects in the files archived, we're coming to a total defects rate, and which is in the files which are rejected around 2.16 defects per file, and in the files to be archived around 0.36 defects, which means that actually in the archived files we have roughly six times less issues than in the rejected ones. That's good, since it shows that the service provider is doing a good job, and it shows that such a QC system is really helping in finding issues and reducing issues. It will never be zero, but a factor of 6 is a significant amount of reduction of problems in digitized files. With this, I would like to give back to Daryl, and he can give us a bit more information on how these operational numbers evolved over the last 3 years. Thank you.
Thanks, Peter. The goal of QC in a real mass digitization project such as this is to detect systematic scanning equipment issues and individual scanning mastering issues. I mentioned earlier the audio problems that we had early on in the project. You can see in March of 2018, that's when we switched from the optical reader to the image-based sound reader, which introduced interstitial errors, and that consequently caused a greater number of rescans. You can also see in July of 2018, we had a scanning issue with new negative stocks, which created crushing, which was something that we found in VidiCert and was able to fix. We also had a film cleaner problem in July of 2018, which just led to a greater number of rescans for that particular month. The crookedness issue that I mentioned earlier happened in February of 2019. You can see that we identified varying degrees of crookedness in several scans, which led to more failures. That was fixed with an adjustment to the scanner software. We also had VidiCert add grid lines to the new version of VidiCert for this reason, so we can identify crookedness if it ever pops up again. You can see in the fall of 2019, there was a little bit less output. This was due to a third scanner being added by the vendor to their setup, and this required them to bring down their storage and add more storage to accommodate that new scanner and that throughput. You can also see the obvious negative effect that COVID had on our project in the spring of 2020. We found out on March 10th that Indiana University, after an extended spring break, will be going fully online and only essential employees will be allowed on campus. So we had to very quickly move everyone home, get them all the equipment they needed and remote desktop set up so they would be able to remote into their PC at work and continue to QC the backlog. Our vendor was shut down in late March due to the governor's stay-at-home order. That wasn't lifted until May, and as you can see, it was a bit of a ramp up from there. You can also see in the fall, in August and September, there's a little bit less output, and that's due mainly because we were doing a lot of 35mm projection prints, which were scanned at 4K. They were a little bit difficult, and of course, the added time of scanning 4K, so it makes the numbers look a little bit lower. And that's something that we've really seen project-wide, that the output and your rescan rate is really dependent on the content you're working through at a particular time. Sometimes we do request rescans for reasons other than scanning issues. For example, frame rate, which can be hard for the scanner operator to identify at the scanner. So a lot of times it falls on us to identify or confirm whether the film was scanned at the correct frame rate for silent content. This is why we asked for and received a variable frame rate adjustment tool in the latest version of VidiCert. Prior to the addition of this, we were having to put files in a separate video editor to check frame rate, and this has really streamlined our process immensely. Some conclusions that we can draw. It is widely accepted within and outside of the MDPI project that our approach to QC is a project strength. It allows IU to better understand its diverse collections and adaptive workflows, enables high-quality archival package, ensures our packages all meet the archival standards that were set forth at the beginning of this project. In regards to VidiCert, you have seen today, it integrates very well within our workflow and our submission package QC. Image and audio issues can be detected very quickly. Detailed automatic and interactive detection functions help in the finding of the origin of an issue. And our QC and rescan reduces the total defects rate by a factor of more than 6. Looking back, it's hard to see how we could have done what we have done without the VidiCert interface, the automatic features, and the tools that are provided within the program. I haven't seen any other solutions that quite match what we have. Our QC strengthens our relationship with the service provider. Obviously, there is always a rub between production and quality control, especially when you're dealing with a public-private partnership such as we have. But I've found the more objective you can make the process, the smoother the experience. That is why the evidence that VidiCert allows us to collect and to communicate to the vendor has been so important within this project. Ultimately, we all want the same outcome, and I believe our QC process gets us to that goal. Lastly, our relationship and support from Peter and the other folks involved with VidiCert has been fantastic. They respond within hours and usually have an answer shortly thereafter. We had great training in the beginning, so if it looks a little overwhelming right now, they are able to break it down and explain the interface very well so you can get to work. And on the flip side, we've been able to provide them feedback about what works well, what could use some work, and some of the features that would be useful. And we've already mentioned some of these in this presentation that have been added to the newest version of VidiCert that were our suggestions. That concludes our presentation for today. We look forward to your questions. Please feel free to reach out to us at the contact information on the screen.